Hello and welcome to the TID Water and Power Podcast. I'm your host, Constance Anderson, and on this month's episode, we're discussing the district's Solar Over Canals pilot project, Project Nexus. Since 2022, TID and its partners on the project have been working on Project Nexus, an innovative pilot that covers portions of TID's irrigation canals with solar arrays. The project, a first in the state of California, has the potential to provide benefits including renewable energy generation, reduction in aquatic growth, and much more. But it's not without its challenges. On this episode, I'm joined by TID's Civil Engineering Department Manager, Bill Penney, to discuss the recently completed project, the challenges of constructing a first-of-its-kind pilot, and what's next for Project Nexus. Bill, thank you for joining us.
Great to be here, Constance.
Excellent. So if you would, let's have you start out by giving us a little bit about your background with the district and before.
Sure. So I joined the Turlock Irrigation District back in 2016. I was hired initially as an associate civil engineer. Prior to coming to TID, I worked in the private industry as a consultant. I've always been involved with development projects. My family has a background in agriculture, so I was very excited when I got the opportunity to come here. Recently, getting the opportunity to become the Civil Engineering Department Manager is something I'm looking forward to.
Excellent. And congratulations on that, by the way.
Thank you.
Good for you and good for the district as well. We first talked about Project Nexus on the podcast way back in episode 11, around 3.5 years ago, if you can believe that. While the project and even the concept at the time were in their infancy back then, we now have exciting news to share about the project. So high level, Bill, can you tell me what is Project Nexus and where are we in the project?
At its very simplest description, Project Nexus is a pilot project to install solar arrays over irrigation canals. It's a project that we like to say is a public-private academic partnership. So there's 4 main project partners: TID, Department of Water Resources, Solar Aquagrid, and the UC Merced research team. Through the planning for Project Nexus, we identified 2 locations within TID's irrigation system to apply this concept and see what its benefits were. Not only is this project going to generate renewable power, but there's also a lot of co-benefits that we expect to come from it. At the end of the day, we've developed 2 sites. Combined, they will be generating approximately 1.6 megawatts of renewable power and cover approximately 1,700 linear feet of TID's irrigation canal system.
Fantastic. Okay, so let's get into each of those 2 locations a little bit more, maybe starting with what we call the narrow span.
A very, very exciting naming convention that we came up with for the project.
Could get a little more creative on that one, I suppose, but we'll save that for another day.
Sure. So the 2 sites we pursued, one being the narrow span site, surprisingly covers the more narrow canals. Each canal covers 2 canals. Each canal is approximately 20 feet wide. Combined, the 2 arrays cover approximately 1,400 linear feet of canal. The site produces just over 800 kilowatts of power. And what's unique to this site as compared to the other site is that it includes 2 75 kilowatt batteries. So at this site, we're able to look at the combination of the solar generating facilities with the batteries.
Now, how does that work exactly? Because this spot was chosen in part because it's adjacent to our power infrastructure. And so are we feeding the power generated by the solar panels at the narrow span back onto the grid, or are we applying that power to the batteries for use at a later time?
So the power being generated from the arrays at the narrow span site, it can go either directly to the power grid or it can be stored inside the batteries. So one of the benefits of having the batteries there is that the energy can be discharged at times when the solar is not being generated. The site is also adjacent to one of TID's irrigation regulating reservoirs, which have 4 large hydraulic pumps. So one of the things we're really interested in researching are the interactions of discharging the batteries and powering those pumps in times where power is not being generated from the solar arrays.
That makes sense, yeah. Very good. All right. And so the project at the narrow span site then is fully completed and generating?
Correct. So earlier this year, back in March of 2025, we successfully completed and commissioned the arrays. So for the past 8 months or so, they've been generating power. Okay,
fantastic. All right, then let's jump over to the wide span, which is out in the Hickman area, yes?
Correct. So the other project location we've called the wide span site, and it's in the upper reaches of TID's canal system out in Hickman. It covers a canal that's approximately 115 feet wide. And even though it only covers about 300 linear feet of the canal, it's almost identical in size. So at this site, it's expected to generate just under 800 kilowatts of power. But both this site and the narrow span site include almost the same number of solar panels.
Oh, interesting.
And at this site, we just wrapped up construction at the end of August. So it's just now starting to generate power. And unlike the narrow span site, it delivers power directly to the electrical feeders, directly to the electrical grid. There are no batteries at the wide span site.
Okay. And just out of curiosity, why was the decision made to not include batteries at the wide span site?
We kicked around the ideas in the initial planning of, do we want to install batteries at both sites? Ultimately, it came down to a decision of feasibility and limitations of the pilot project. There's efficiencies to only include batteries at one of the sites. So we feel we're going to be able to understand the interactions between the solar and the batteries just as well at a single site as compared to having them at both sites.
Yeah, fair enough. So you mentioned earlier that TID has teamed up with some partners on this project and referenced the academic public-private partnership. Can you tell me a little bit more about each of these partners and what their contribution was to the pilot?
Sure. So each of the 4 project partners have, significant roles within themselves. So DWR, their main role for the project is to administer the project and administer the funding that's coming from the state of California for the pilot project. UC Merced, their role is to acquire a lot of the data and analyze and research the data that's coming from this project to really quantify these co-benefits that we expect from this solar over canals concept. The 4th project partner, which represents the private side of the partnership, is Solar Aquagrid, and they had a large role in getting the funding together for this project, helping to fund an earlier research paper by UC Merced, and their role on Project Nexus is as program manager.
Okay, very good. So you mentioned that the project was state funded. What kind of an amount are we talking went into the project?
So back in the state's budget in 2022, they allocated $20 million towards the Solar Over Canals pilot project.
Okay, excellent. And everything stayed on budget?
We are within budget.
Excellent. Congratulations.
Thank you.
That in and of itself is a win. All right. Okay, so let's talk a little bit about the project history and kind of where this concept came from. So we talked a little bit about that back on episode 11, but for those who haven't listened to that episode yet, can you kind of walk us through how TID got involved in this in the first place?
So the way we like to tell the story, and it probably even goes on before this, but back in 2021, the UC Merced research team published a paper summarizing the co-benefits for installing solar arrays over all of the state of California's canals. That research paper, led by the UC team and also Solar Aquagrid, was proposed to the state to show, hey, here are some real benefits to potentially solve your energy and water crises that are occurring in the state and will only get worse.
Sure.
So outlined in that research paper was, the significant co-benefits that we've identified are the renewable energy benefits, but also the reduced evaporation. The shading from the arrays should reduce and put a cap on the evaporation that come from these open canal systems. And TID also sees a lot of benefits specifically for reduced vegetation. TID puts forth resources every year to clean the canals and clear the vegetation that otherwise could potentially clog side gates, reduce capacity, all those types of things. So that's a very direct benefit for TID.
Absolutely.
So after the state became interested and it became aware that the state was looking for a canal operator to potentially host this pilot project, TID raised their hand and said, hey, we're interested. We have a willingness to pilot this. It's really in our DNA to pursue new ideas, to test ideas. We've tested other ideas before in our canal system, and we're not afraid to try something new. And one of the main benefits for TID for this pilot project is that we provide both a canal, we operate and maintain a canal, but we also are our own balancing authority. So as a lot of other canal operators would have to find some sort of partnership or agreement with a power provider, it was seamless for us and really greatly reduced the time, efforts, and likely cost to have this interaction between the arrays and the canals. So ultimately, TID was selected as the host for this pilot project. Okay.
So you mentioned, that we're not one to shy away from new ideas and exploring new concepts. We are, after all, the first special district in the state of California. So it kind of is in our DNA, as you said. But why were we so interested specifically in this project?
One of the leading reasons why TID was so interested in doing this project is the requirements in the future, the near future, to be 100% carbon free. We feel like, and we have a willingness to consider all options. And while TID owns and operates 250 miles of canal, the co-benefits explained in the UC Merced research paper really made it seem like this could be a viable option to either apply everywhere or in select locations where it can help us get to those 2045 carbon-free requirements.
Absolutely. And I want to go back for a second. Why was the state so interested in this project? What are the implications of Project Nexus where the state's concerned?
For very similar reasons as why TID was. They're in a position where they have an energy and water crisis, and they also operate their own canals, and they want to show or see if this is a viable option for them to consider installing over their California aqueduct, which is a canal that runs, along the center of the state. It provides a lot of drinking water to Southern California, and TID's canal system, notably the wide span site, was a representation of that. And they wanted to see, is this scalable? Mm-hmm. Is this something we can install at a level where it's really going to make a significant impact for the issues that the state's being faced with?
Okay. All right. So you served as the project manager for Project Nexus, and as such oversaw the construction of this truly historic project. But it's not like it came with a blueprint. You didn't really have a set of plans that you were building from when you started this. It was literally all brand new. Can you walk me through what the construction was like and what it took to get this project built?
It was a challenge. It was definitely a challenge. The UC Merced research paper considered a new type of technology, a prototype, so to speak, that utilized tension cables as the primary backbone of the structure. There are a lot of expectations that would be more feasible. This would require less material for the structure, it'd be more lightweight, and ultimately would be quicker to install. Unfortunately, after spending a lot of effort to design and engineer that system, seek qualified, interested contractors, got to a point where we just needed to pivot and go to a more traditional elevated solar canopy. But it was very difficult, I think, for me, getting from a research-based idea, a research-based concept, and applying that and developing it and being practical with it was just difficult.
Sure.
But very rewarding, to where we are now, to see all the efforts, all the good times, the bad times that we've had on this project. It's been very rewarding to work on this project.
Excellent. So what were some of the issues with the original kind of concept of that cable tension system?
Ultimately, it came down to finding interested, qualified contractors that were willing to construct the facility under normal contract terms and conditions. We were able to engage with several contractors that were interested, but for various reasons weren't able to continue working on the project. So ultimately it came down to a decision based on feasibility, but also the schedule of the pilot project. The pilot project was originally intended to run from 2022 through the middle of 2026. So we knew that we not only needed to construct the facilities during that period, but we also needed to allow enough time for the UC Merced research team to acquire the data, analyze it, and then ultimately report out on the co-benefits. So we couldn't construct, late into that season. We really wanted to leave ourselves a season or two to acquire the data.
Sure, absolutely. So ultimately, how was the design selected?
Long story short, we ultimately engaged with a general contractor through a competitive procurement process that was able to bring to us a solar array concept that was more readily available. There were more contractors that were familiar with constructing facilities similar to it, and it could meet ultimately our timelines, but also came at a much reduced cost as compared to the tension cable design that we had been pursuing prior to that.
And did you go through kind of that same design process for both of the sites?
Sure, yeah, I should have specified. So the process I just described was for the narrow span site. For the wide span site, we were afforded a little bit more time, and we had the opportunity to go out and request unique designs from the construction market. And we had 6 interested firms submit their own unique designs to span the wide span site. So through that process, we were able to evaluate a number of different options, design concepts, and compare them to our overall project goals, costs, schedule, and we were able to identify a preferred contractor for the wide span site.
Okay. So I want to ask you a little bit more about kind of the specifics of each of these sites. But first, I want to remind our listeners that you're building this on a canal bank. So it's not like we have a chunk of perfectly level land where we can spread out and, really anchor this thing as you would a building or any other traditional civil project. You've got some very specific parameters that you're working against, and you have an operational canal that you're building this over. So tell us a little bit about what kind of each of the narrow span and the wide span, the actual structures are like.
Yes, it was a challenge. The narrow access roads, water in the canal, definitely created a unique set of circumstances for the project. At the end of the day, as I've mentioned before, we installed 2 arrays at the narrow span site. In total, the narrow span site has 108 concrete and steel rebar foundations. On top of those foundations, there are steel columns, and on top of those columns are what are called cassettes. And those cassettes are, essentially form the canopy of the solar array. Similar types of building components for the wide span site covers a much shorter distance of canal. So for that site, there are only 14 concrete and steel rebar foundations with columns on top of that, and then an arched structure that the cassettes form. It's on 4 different planes. So similar building members, but definitely the structures look different, and that's really based on the need to span the canals and not have any of the structure within the canal impeding maintenance or operations.
Right, absolutely, because these are working canals that our crews have to be in regularly for maintenance, for repairs, and running water through them.
Right, and while we definitely made attempts to maximize power generation and minimize costs of the structures, really one of TID's focuses going into this project was to minimize canal operations and maintenance as much as possible. And I think we've really, to a large degree, achieved that goal.
Excellent. Very good. So when we're talking about, having access to the canals and working in the canals, what sort of clearances did you have to bear in mind, or did the design have to take into account at each of the sites?
When you compare our final designs to the initial research expectations, I think this is something where there is a pretty big gap. And the need for that was we needed to elevate the structures so that we could get O&M personnel and equipment under the arrays to maintain the canals. We needed to make sure that really on both sides of the canal we could achieve that. So on the low side of the array at the narrow span site, there's a minimum height of 8 feet, and then there's a angle to the canopy. And on the high side, it was a minimum of 14 feet. And the 14 feet was for getting an excavator underneath the array and into the canal. Similar vertical clearances were required on the wide span site, but because of the arched structure, it resulted in both sides having a minimum clearance of 14 feet so that we could have construction equipment get underneath it.
Okay.
And one other significant requirement that the structure needed to account for was the potential of a canal washout. These don't happen all the time, but they do happen. And usually it's in the middle of a night during the rainstorm when it's peak irrigation season.
Yeah.
You just kind of got all the things coming together, and we do a tremendous effort to get the canals back in operation as quickly as possible. And the last thing we wanted was to have a failed structure, solar structure, in the canal while we're trying to get it back in service.
Yeah.
So the structures themselves are made to withstand having a canal washout occur. So if the canal washes out, the structure will still remain standing. Will still hold.
Okay. All right. So typically any sort of construction that we're doing, or, the maintenance and repairs that we've talked about in and around our canals, happen in the irrigation off season, which is traditionally November through February. That's when the canals are empty. We're not running irrigation water. Did Project Nexus follow this construction window?
We hoped it would have. But unfortunately for the narrow span site, specifically for the schedule constraints that we were faced with and the changes in the project we had to make just before construction, we weren't able to install the foundations, which were of utmost concern during the non-irrigation season, but we were able to install them before the peak irrigation season started. So while the foundations were being installed, we were able to keep the water elevations in the canal lower than they otherwise would be during the peak season. So we did have more time to plan that out, and on the wide span site, we were able to install the foundations before the irrigation season started. Another constraint that we encountered at the narrow span site was the proximity of a overhead transmission line.
Oh, sure.
So the transmission lines have been there for a long time, and we knew that the structure itself would not interfere with the clearances that are required from the transmission lines. But based on the means and methods of installation of the structure, the use of man lifts and the use of cranes, we did get a little closer than we would have liked. So for that particular stretch of the array, we had to wait during a time in TID's season to take an outage on the transmission line. So ultimately, it delayed things a bit to install that portion of the array, but overall, it really didn't have a significant impact on the overall project. And keeping safety top of mind, as we do at TID, that was an important consideration. Absolutely. No reason to put anybody in any additional risk or harm than they otherwise would be. So we were able to accommodate it, and things worked out great. Okay. All right. So we've talked about some of the challenges with the design and the timeline. Any other challenges that cropped up during the process? As I've mentioned before, there definitely were a number of challenges that came up on this project. Maybe a couple more to explain a little bit further was one of them being the accessibility during construction. typically at a construction site, there's a large laydown area where parts and pieces can be fabricated before they get installed. There's also usually open spaces for equipment to maneuver. Especially on the narrow span site, we had neither of those. So we actually, before the project started, we had to widen the canal banks a bit to accommodate both post-construction canal and electrical equipment. But a side benefit came with, hey, that actually gives us more accessibility during construction. So site accessibility and maneuverability are going to be a challenge not only on our project, but any future solar over canals project. And then, again, I mentioned this before, but taking a concept, a research-based idea, and making it reality is difficult. I think we did our best to achieve all of the goals that we had set out to do and give ourselves an opportunity to collect data and analyze all of the co-benefits that we expect to come through this idea. But getting it from an idea to an acceptable design to a constructible idea and then constructing it, it's difficult.
Those seem like all very different things.
Yes. and we all really at the end of the day came together and utilized a lot of expertise from a lot of different people that have a lot of different backgrounds to really achieve, I think, what we all set out to achieve.
Yeah, that's fantastic. And I think it does, it speaks to, again, the innovation and the kind of the beauty of the project is there was a concept, there was an idea, and you went down a lot of different roads and put in a number of different hours to figure out how to make it happen. And ultimately, you did.
Right.
Yeah.
Right.
So that's fantastic. Now, when Project Nexus was announced, it was originally going to be the first in the nation project, of its kind anyway. And ultimately, it ended up being the first in the state because there was a project in Arizona, a similar project, completed prior to Project Nexus. Can you tell me about that project a little bit and what maybe some of the similarities and differences are?
Yeah. So when we started this project, I did my research and it was apparent there were other people thinking of this idea and people had thought of it before. We were expecting to have the first constructed arrays over canals when we began our journey. But this project in Arizona was completed before ours. Exciting to see.
Yeah.
It's exciting to see the differences in the designs they were able to deploy as compared to ours. I'm not completely aware of all the circumstances for their canals, but one very notable difference is that their solar canopies are placed much lower and closer to the tops of the canals than ours. As I mentioned before, there are very specific reasons why TID required the structures to be elevated. But it was exciting to see it. And we were able to see it, look at it, analyze it, and try and apply it as best we could to the efforts we currently were in the middle of.
Absolutely. And the learning from their project, the learning from our projects, it all goes to benefit the next organization that tries this avenue.
Absolutely. I love to learn from other people. I love to ask people questions. And from the outset, I felt that our project was just going to be the first of hopefully many, and people can learn from us, and we can just continue to make this idea better.
Absolutely. Right on. All right. So looking ahead, now that Project Nexus, both locations are complete and generating, what's next? What happens at these facilities going forward?
So since their completion, each site is delivering power to TID's electric grid for TID to manage and use. The other main component now is TID staff becoming familiar with the systems and how they need to be operated, how they need to be maintained, specifically for the array's frequency of cleaning. Each array is right in the heart of some of the most prime farmland in the world. A lot of dust.
A lot of dust.
So just doing some analysis on frequency of cleaning, when during the year to clean, what those benefits return, how much power generation does that result in?
Yeah.
That's all stuff TID staff is really just in the beginning stages of learning.
Because just as this project didn't come with a blueprint for how to build it, it didn't come with any instruction as to how to clean it and keep it operational.
You're absolutely right. So there's a lot of ideas and expectations for what this is all going to take, but we're really at the early stages to understanding that.
And what about the research you mentioned? You said that UC Merced will continue to collect data and do research on the project. What sort of information are they looking to gather?
A lot of research. So another main component right now is to acquire all the data from UC Merced's instrumentation to begin quantifying these co-benefits that I keep bringing up that we've set out and identified with key performance indicators. And then once we're able to quantify that, we need to place a value on it. So really those co-benefits are going to have a net reduction on cost. And that's a really important thing or criteria that us as a project team is interested in understanding so that we can really explain all in what does it take to do this?
Yeah.
How does it compare to more traditional types of solar projects? So that's really where we're at right now, is to begin understanding that, and then ultimately writing all of that in a report. So we've begun drafting 2 different reports. One of the reports is going to be more focused on the design, engineering, and construction aspects of the project. And then the other part is going to be primarily written by the UC Merced team, is going to be focused on the research.
Excellent. Okay. What else as we look ahead to the future of Project Nexus?
So there is one more component that we are planning to construct. It's this prototype structure out of Australia. We've been working with a company for about a year now, and that structure is called Solar Waves. So it's a structure that's going to sit much lower to the canal, but it has the ability to retract. So one of the reasons why we had to elevate the other structures is so that we could still access our canal. So with the ability to retract this Solar Waves prototype, it gives us that ability while still sitting much lower to the canal. So later this year, we plan to receive that equipment and install it. And then, with the time we have remaining with the pilot project, begin understanding its co-benefits and how they compare to the other arrays that have been installed.
And what would you suspect will be some of the additional benefits of having the arrays that sit lower to the canal? Anything different than the existing Project Nexus sites?
I think one thing that just seems to make sense is that it, in theory, should further cap the evaporation. One of the things I think we're losing with the elevated structure is a bit of evaporation savings. We've already collected some data at this point that shows we are putting a cap on evaporation.
Oh, great.
But having the structure closer to the water surface, I think, will just mitigate that more. Also, the structure is smaller, and therefore the structural components are smaller. Costs should be less. So again, just like with our expectations for this concept, there seem to be a lot of co-benefits. So we're very interested in being able to install this system, which will be fully installed by TID construction and maintenance personnel, which is another thing for us to be very proud of, and begin comparing it to the other arrays. And like I said, I feel like we're making the initial steps, and from here on out, it's how do we make this idea better? How do we make it more efficient? And hopefully, this is a step in the right direction.
Absolutely. Well, we look forward to having you back at some point in the future to give us the update on what sort of results and data have come from the first few years of Project Nexus. Bill, before we let you go, anything else that you want to make note of with regard to Project Nexus and where it goes from here.
Yeah, I've commented a few times about just a sense of pride with this project. And recently I was going through, for whatever reason, and identifying people who have had more than just an insignificant role on the project, but people who really spent time, whether it was doing a power study, an electrical study, whether it was assisting with running a new electrical feeder, whether it was, widening the canal banks. Dozens of TID staff had a role in this project to make it a success. And having all the different trades, all the different backgrounds, all the different positions at TID come together and really be able to take a step back and say, hey, I had a role in that project. I think that's pretty cool to see that. And years going forward, people are going to be able to look at that and say that. And I think that really shows not only the willingness for TID to take on this challenge, but it shows how we're able to step up and solve what really was a difficult problem. Absolutely.
And that's a theme that's come up more than once on our podcast episodes, is just the talent and the expertise here at TID and the various ways in which we're able to capitalize on that for the benefit of our customers ultimately. Very good. Well, Bill, thanks so much for joining us. Like I said, we look forward to the next update on Project Nexus, and we're happy to have this update from you today. So thanks for being here.
Thank you very much.
Thank you for tuning in to the TID Water and Power Podcast. You can find TID on Facebook at facebook.com/TurlockID, on Instagram and Twitter at TurlockID, and on LinkedIn as the Turlock Irrigation District. I'm your host, Constance Anderson. We'll see you again next time.